The compound microscope you have asked for. So compound microscope has two lenses. One is objective lens, one is eyepiece lens. So I'm writing it down. This is your objective lens. Okay, this is objective lens and this is your eyepiece lens. Clear? Now this over here, this is your object, the small object which you are going to see. So basically this object, the height of the object, we are giving it a name as h, the height of the object. Now the distance from the object to the objective lens, this is basically, if you see properly, for this lens, this is the object. So the distance between them should be the object distance. But this is the object distance for which lens? Objective lens. So basically when we mention this distance, this is the object distance but for objective lens. So therefore UO. Now from here, the next part, here because of the object over here, at first the image is created over here because of the objective lens. So this is your object, this is your objective lens. For the lens, the first image is being created over here. The height, we are saying it as h dash, and the distance basically, that means the objective lens to the distance where the first image is forming, that means basically till here. This distance is what? This is the image for the objective lens, right? This is happening because two light rays after refraction are meeting at this point. So this is an image for the objective lens. So this is your image distance but for the objective lens. So therefore it is VO. Clear? So first object, then image for the objective lens. Done. Now for the eyepiece lens. Now this image which already has formed is going to act as the object for the eyepiece lens. Okay, this h dash now is the object for the eyepiece lens. So basically this distance over here, it is what? This is object, this is lens. So this should be the object distance, but for which lens? Eyepiece lens. So this is your object distance for eyepiece lens, UE, right? And final image is forming over here. Final image is forming over here from the eyepiece lens at a certain distance. This distance is basically what? This is the final image. So this should be the image distance mentioned with V, and this is image for the eyepiece lens. So this should be VE. And according to our derivation, we consider this image is forming at a distance of least distance of distinct view. So we mention it as D, least distance of distinct view. So till here it is clear. Two lenses are there, objective lens, eyepiece lens. First image at a distance of UO, object distance for the objective lens. First image for the objective lens here. This is image distance for the objective lens. This image is acting as the object for the eyepiece lens. So this distance is object distance for eyepiece lens, and this is the final image forming. So this is the object distance for our eyepiece lens, which is equivalent to D. Now if we have to find out magnification, okay, we have to have two conditions. One, the final image that is forming, okay, is making a certain angle with the eyepiece lens. That angle we have to find out. So this is the final image. If I consider a light ray coming like this till eyepiece lens, the angle that is being made over here is considered as beta. So final image making an angle of beta with the eyepiece lens. Okay, beta you have to find out. Similarly, you have to find out another angle, that is if the object, if I shift it from here to the position of the final image, if I shift the object, this object, if I shift it from its position to over here, okay, and if I keep it over here like this, this is going to make another angle with the eyepiece lens. That angle will be alpha. So as I am not drawing it over here, I am drawing it separately. Okay, I am considering this object, initial object is shifted to this point D, this point, and eyepiece lens. So basically if I shift the object from here to here, from here to the eyepiece lens distance is what? D. So I am considering from this, the lens position is at D. So what the angle will be made over here? This is alpha. And this is the object we have taken. So height was h. So HD. Now if I have to find out the magnification formula is beta by alpha. Okay, I told you, for if beta and alpha, these angles are very small, then whatever their values can also be taken as the value equal to the tangent of it. Means whatever beta by alpha will be equal to tan beta by tan alpha. This can be taken. Only for sine and tan we can take it if the angle is very small. Tan beta by tan alpha. So basically what we have to do, we have to find out tan beta and tan alpha separate. So first tan beta from the diagram we have to find out. So here in the diagram, what is tan beta? This is beta. So here a triangle is being made, this triangle. Correct? If I have to find out tan beta over here, tan beta is opposite by adjacent. So h dashed by this distance which is equal to ue. So tan beta is going to be h dashed by ue. Similarly, tan alpha also you have to find out. Now tan alpha is what here? Tan alpha means opposite by adjacent. Opposite is h, adjacent is d. So tan alpha is going to be h by d. So tan beta and tan alpha you have found out. Now for magnification, we are going to substitute them in the place of tan beta and tan alpha. So we are going to write tan beta as h dashed by ue divided by tan alpha is h by d. So if I do it, h dashed by ue into, this is going to be reciprocal, so d by h. So if I just rearrange them, it becomes h dashed by h into d by ue. Remember this, h dashed by h and d by ue. Now from the diagram again, h dashed by h is what? See, h dashed is this. Now this was basically the image formed by the objective lens. So h dashed is the image height for the objective lens and h is the object height for the objective lens. So h dashed by h is image height by object height for objective lens, and image height by object height basically is the magnification of the lens. So h dashed by h is the magnification of the objective lens. So we can write h dashed by h is basically the magnification of the objective lens. Very similarly, the second part was d by ue. So in the diagram, what is d by ue? D is this final image distance. Ue was here. For eyepiece lens, this was considered as object. So this was object distance and this is image distance. So d by ue basically is image distance by object distance. That is another formula of magnification for the specific lens. So image distance by object distance is the magnification of the lens. So this is eyepiece lens. Therefore, d by ue is magnification of the eyepiece lens. So we will write d by ue is the magnification of eyepiece lens. So we can substitute them. It is MO into, this is ME. So magnification of the compound microscope can be written as MO into ME. Okay. Now slowly, one by one, another part is there. MO into ME. Okay. MO was h dashed by h. H dashed by h. So from the diagram, if you look at the diagram one more time, see, h dashed by h, magnification of the objective lens. Another formula for the magnification of a lens is image distance by object distance. So if the magnification is h dashed by h, that is object distance, the image height by object height can also be equal to object distance and image distance ratio, means image distance by object distance. So h dashed by h can also be written as VO by UO. I'm just going to substitute it over there. that this can also be expressed as VO by UO. Then this is the MO you have simplified. ME. ME was what? ME was D by UE. Okay, so we could have kept it over here like this, but D by UE we have to find out a proper relation for these two. So D by UE we will not keep it like this, we will use Lenz's formula, the simple Lenz's formula. Using Lenz's formula. Okay, D by UE. What is Lenz's formula? 1 by V minus 1 by U is equal to 1 by F. Okay, this is magnification of eyepiece lens. So all V, U, F, all they will be for the eyepiece lens. So it will be 1 by VE minus 1 by UE is equal to 1 by FE. Okay, VE. VE is equal to D. Negative because on the left side of the lens. So this is negative UE. This distance. Left side of the lens. So negative. So we will substitute them over here as 1 by V was D, so minus D, minus 1 by UE was minus UE is equal to 1 by FE. Why FE is positive? Because it is a convex lens. Convex lens focal length is positive. So what will happen? 1 by FE. Achha, let's keep it like this. First change it. This minus minus plus, so 1 by UE minus 1 by D is equal to 1 by FE. So therefore, if I take this to this side, it becomes 1 by UE is equal to 1 by FE plus 1 by D. Now, I have to find out an expression for D by UE. So on both the side, I will multiply D. So on both the side by multiplying D, we are getting D by UE is equal to D by FE plus D by D cancels out, so 1. So basically D by UE can be written as 1 plus D by FE. Okay, this is 1 D by. So this we can substitute over here in ME. So ME can be written as 1 plus D by FE. ME done. So magnification was MO into ME. Okay, MO, we have found out VO by UO. So MO was VO by UO into ME was 1 plus D by FE. So 1 plus D by FE. So final magnification formula, VO by UO into 1 plus D by FE. Okay, this is the final magnification. It is for when the image is placed at D. When the image is formed at